Bismillahirrahmanirrahim. In this session, we will discuss the integration of functions of the form 1 upon x and 1 upon ax plus b. If previously we have differentiated logarithmic function to obtain this 1 over x. So whenever we differentiate ln x by d by dx, then we if we differentiate this ln x with respect to x, then we get this 1 over x, where x is greater than 0. Similarly, for dy by dx, we have ln ax plus b. Then if we differentiate this, then it becomes 1 over ax plus b, and then we differentiate this part to get this a. So here ax plus b is greater than 0. So this is greater than 0, then this is valid statement. Similarly, for this, if we integrate this 1 over x, then we'll get this ln x plus constant values. So this for x is greater than 0. Similarly, for this one, if we integrate this 1 over ax plus b, then we get this ln ax plus b, and this a is here. So we integrate and we get this one a plus c, so where ax plus b is greater than 0. So this is simple rule we will use to solve various problems. So in this session we'll discuss exercise 15.6, which is very important, and we'll solve some of problems from question 1 and then question number 2, and afterward we will solve all other questions. So here we have this 8 upon x dx, then this 8 is constant, and then dy by dx is ln x plus c. Similarly, for this 5 upon 3, so this 5 upon 3 there, and ln x, so dy by dx ln x plus c. Similarly, for this 1 over 3x plus 2, 1 over 3, because of this 3, and this, because this is a and this is b, so this is a ln 3x plus 2 plus c. Similarly, for this 1 minus 8ax d by dx, this is 1 over minus 8, so this is minus here, so ln 1 minus 8x plus c. Similarly, for this 7 by 2, and then ln x, this 7 is here, and then this 2 of this 2 plus c, 4 is here, and this 3 is here. So this is in part 2. We have 7x plus 1 plus 2 upon x dx. This is 7x square upon 2. This is x, and this is 2 ln x plus c. Similarly, for this one, and for this part, 5x plus 2x upon x square. So this is 5 upon x plus 2 upon x under root x. So this is 5 ln x, and this is solved by 2x power 3 minus 2 plus 1 minus 3 upon 2 plus 1 plus c. So this on simplification we get this minus 4 upon under root x and plus c. So 5 ln x minus 4 upon under root x plus c. Similarly, for this last one, I 5x e power 4x minus 2 e power x 10x e power x dx. So this on simplification, 5x upon e 10 power x, this is 10, x will cancel with this one, and then 5 upon 10 is 1 over 2, and this is x, this is 4x, so 3x will remain there. So for this, from this part we have this x e power x cancel, and then this 1 over 5 x, so this becomes ln 1 over 5 ln x, this is here, and from this 1 over 2 e power 3x upon 3, and then plus c. So on this 3 multiply with this, so 1 over 6 e power 3x minus 1 over 5 ln x plus c. So this is part 2 questions, last part, and Here we now go to the question number 3. A curve is such that dy by dx is equal to 5 upon 2x minus 1 for x greater than 0.5. Given that the curve passes through the point, this curve, this is the gradient of the curve, and the curve actually passes through the point 1, comma 3. On integrating this, we will have a curve. And find the equation of the curve. So this curve is passing through this point, and we have to find the equation of the curve. So we have to integrate it. So on integrating, we have this 5 over 2 ln 2x minus 1, 2x minus 1 ln 2x minus 1, and this 2 is here and this 5 is here, plus c. Now this curve, since this curve is passing through the point 1, comma 3 as given, so in place of x we will place 1, and in place of y we will place 3. So 3 here, 5.2 ln 2, and then x, in place of x is 1 minus 1 plus c. On simplification, this is 2 minus 1 ln 1 is 0, so c is equal to 3. So y is equal to 5.2 ln 2x minus 1 plus 3. So this is the curve, equation of curve, required equation of curve. Now go to the question number 5. A curve is such that dy by dx is equal to 1 over x plus e for x greater than minus e, given that the curve passes through the point e, comma 2 plus ln 2. Find the equation of the curve. So we have to find the equation of the curve, and the curve is passing through this point e, 2 plus ln plus 2. So this part dy by dx 1x plus e for x is greater than minus e. So this becomes not 0. So if x is greater than minus e, then this part will be greater than 0, and it will be valid statement. So on integrating it, we have this y is equal to ln x plus e plus c. And since this curve is passing through this point e plus e comma 2 ln 2, so in place of x we will place this e, in place of x we will place this e, and in place of y we will place this 2 plus ln 2, in place of y 2 plus ln 2. So in place of y 2 ln plus 2 ln, in place of x we will place this e plus c. So this is ln 2e, this is 2 plus ln 2. So this is ln 2 ln e, this is 1, this is ln 2 ln 2 cancel out, so this is 2, and this is 1 plus c. So c is 1. So this curve y, in place of c we will write this one. So y is equal to ln x plus e plus 1. So question number 6, a very challenging question here. The point p1 comma minus 2 lies on the curve for which dy by dx is equal to 3 minus 2 upon x. The point q also lies on the curve. The point this lies on the curve for which this. So we have a gradient of the curve, and we have to find the curve. That curve lies on the point. The point lies on the curve. So this point is lies on the curve. So the curve is basically the integral of this gradient, and this point q is also lies on the curve. So by using these two relations, find the value of this k. So we have to find this k, and in the next part, the tangent to the curve at the point p and q intersect at the point r. So the tangent to the curve, this is the tangent, the curve at the point p, by placing this point p here and then placing point q here, and it will intersect at some point. So we'll compare it and find the value of coordinates of the point R. So question number 6. So dy by dx, this is the given gradient and passes this point is basically lies on the curve. This is the gradient of the curve, and this point lies on the curve of this gradient. So the curve of this gradient is given as this. So integrating, we have this 3x and this is minus 2 ln x plus c, and since this point lies on this curve, so we will place 1 in place of x and minus 2 in place of y. So minus 2 here, and this in place of x will be write 1 in place of x will write 1 plus c. So this becomes 0 and this is 3 and will be shift here minus 5, so c is equal to minus 5. So c will be minus 5. So this equation can be write down y is equal to 3x minus 2x ln x plus c, and c is minus 5, so c minus 5 is here. So this is the equation for part P with the point P lies on this curve. So similarly for this point also lies on this curve, so we will write this x in place of x we will write 2 and in place of y we will write k. So in place of y we will write k here, and this is 3 2, this is 2 ln 2, and this minus 5 if we take it this equation. So this is minus 5 here, so minus 5 3 to the 6 minus 2 ln 2, so this is 1 minus 2 ln 2, so this is ln 2 power 2, this power comes here, so this is ln 4, so this is k is 1 minus ln 4, so k is obtained. So this is our requirement in question number 1. And part B, we have given that the gradient at this point is on substituting at P, so in place of x we will write this 1, and we have this dy by dx is 1. Similarly for the Q, we have this placing Q2 is here, and then we have this dy by dx is 2. So the equation is for gradient number 1, the equation of line is 1 y, this is minus 2, so here we have minus 2 and this gradient is 1, and x minus, and this one is here. So from this we have y plus 2 x minus 1 and y is equal to x minus 3. So this equation is obtained from this part P with this gradient. So this equation tangent on the curve is obtained as this by using this point, and gradient by this point is passing through the gradient as well. We have assumed this point is also passing through the gradient, so we have obtained the curve as this. Now we will using this equation 2 part 2, and the gradient is used, and we will use the equation of tangent as from this second equation. So this y minus this k, basically this is k is 1 minus ln 4, so 1 minus ln 4, this gradient is 2 and x minus, and this is 2, so we have this 2 here. So we have y is equal to 2x, and this shifts here, so this will become minus 3 and ln 4 minus ln 4, so y is equal to this. So we have this y is equal to x minus 3, and we have y is equal to 2x minus 3 ln 4. So on comparison with this equation with this one, we have x minus 3, because this x minus 3 is also equals to y, and y is also equals to 2x minus 3 minus ln 4. So these two are also equal, so x minus 3. So in this, basically on simultaneously solving, we can obtain the solutions. So on solving this, we have x is equal to ln 4, and from that y, if x is equal to ln 4, so x is equal to ln 4 here, then y can be obtained as 2 ln 4 minus ln 4 minus 3. So ln 4 minus 3, this can be written down as 2 ln 2 minus 3. So because this 2 power 2 and this 2 comes here, so this 2 power 2 and this 2 come here. So this is the answer. This is the answer. So this is very, very important.